Alright folks, going to have a look at the answers to the 28th of March, again going through Foundation Plus up to Higher Plus. These are first aimed at grade 5 and 6, and then Higher's at grade 7, and Higher Plus is at grade 8 and 9, so look at the ones that are relevant to you. Start off with a ratio question. Anna, Beth and Carla share money in a ratio. Carla receives this amount. So when you've got a ratio question, you're basically asking yourself, what type of ratio question have I got? This would be an ADM question if you knew the total amount of money, but we absolutely do not. We know that Carla's got a certain amount. You then, if you know like a certain amount, you've got to ask yourself, do I know a difference between, or do I know an actual amount? And in this case, we do actually know Carla's got 75 quid. So that means we can directly link that up. 5 parts, that's Carla, equals £75 in reality. So if we want to find out how much Beth has got, and Beth is the 3 in this system, you need to say, how do I get from 5 to 75? You get there by times and by 15. So Beth will be £45. Second question, we've got some index rules. So if we want to times indices together, that means we are going to add the powers. And if we want to divide indices, that means we are going to take away the powers. The other mistake I think people can make here is they look at 7 and think that that doesn't have a power, but anything number on its own, that's to the power of 1. So we've got 7 squared times 7 to 3. That's going to give us 7 to the power of 5 by adding the powers. And then if we divide it by 7 to the power of 1, that'll be a subtraction. That'll be 7 to the power of 4. Find the midpoint. So for a midpoint between anything, you want to add and halve the 2 points. So what do I mean by that? I mean that I'm going to add my minus 2 and my 4. That'll give me 2. I'm going to add my 2 and my 9. That'll give me 11. And then I'm going to divide these both by 2. So I'm going to divide that by 2, I'm going to divide that by 2. It'll give me a final answer for my midpoint as being 1, and then 5.5 or 5.5. Okay. Lastly, we've got to complete the table for a graph, and we've got to draw the graph. So this is a quadratic graph. And that means that you can expect a certain amount of symmetry on it. There'll be like a highest point or a lowest point, and then the values will both go up from there or both go down from there. So we're going to use that. Let's work out the positive values first, because that's normally easiest. We want to sub in, x is 2 here. We want to do 4, take away 2 squared. That's 4, take away 4, that is 0. And just be careful when you substitute negative numbers into anything, that if you're raising them to a power, you should really have them in a bracket if you put them into a calculator. If you're doing it in your head, you could just do minus 2 squared is 4, and 4 take away 4 is still 0, but calculator-wise you need that bracket for the calculator to realise that you want to square all of minus 2 and not just the 2. That'll give us 0 as well. Once we've got those points, we can plot them on our graph, and we can see that that symmetry that I was talking about does exist. And you could also go ahead and even say, well, 3 is going to be at 5 as well, because it's the same as minus 3. We then join those points together with as smooth a curve as you can actually do. Obviously, the tablet is not the best sort of device to do this on, so I'll do what I can. I'd end up with that. Okay, so that was Foundation Plus. Let's have a look at Higher. So again, this would be grade 6s and 7s now. Factorize fully. Factorize means put into brackets, and you've got to ask yourself, well, is this going to be 1 bracket or 2 brackets? And if you can, try and take out any common factors right at the start. So 3 goes into both of these terms. I'm going to take that out before I do anything, because it will make factorizing what's left easier. It's important to say that I don't get rid of it. I'm not dividing by 3 so much as I'm taking out a factor of 3. X squared minus 16, I want to find 2 numbers that times to minus 16 and add to 0, or I could recognize this as a difference of 2 squares, which is generally speaking, if you've got anything that's like a square take away a square, then that factorizes to x plus number and x minus number. So in particular, this one will go to x plus 4 and x minus 4. They add to 0, they times to minus 16 as well. And that's it, that's my full factorizing. Okay. Next question. 2 trees selected at random. What's the probability they are both over 2 meters? So to answer this, we need to know 2 things. We need to know how many trees there are and how many trees are over 2 meters. For how many trees there are, we can just add up the frequencies. This will give us a total of 42. And then to get the trees that are over 2 meters, these are the bits of the table that we're interested in. Because this is saying from 2 to 4, 4 to 6, 6 to 8, all of those are bigger than 2 meters. There are 30 trees that are bigger than 2 meters high. So what's the probability that a tree is more than 2 meters? There are 30 such trees out of 42 total. But we want 2 trees. So we need to times this to get the second tree. And we've already picked a tree, so this should now be down to 29. And there is 1 fewer tree to pick from, so this is now down to 41. And then we multiply those 2 things together. And we'd get that the probability that both are over 2 meters is 0.505 or 50.5%. You could have also modelled this as a tree diagram, I suppose. We could have said like over 2 meters, less than 2 meters, and we would have found that like this 30 over 42 and this 29 over 41 were the things we're multiplying together. Okay, circle theorems. So ABC is 24, ABC. So remember when we say ABC, we mean if you were to draw the line A to B to C, what would be the angle in between the two? So if I was to draw that line, it would be the angle between them. Or you could just pick the middle letter. Find angle BAC. So I'm trying to find this angle over here. Let's call that theta. Then we've got this third angle. Now if we know that, we can answer this because we know triangles add up to 180. And this is a circle theorem. Circle theorem here is that there are right angles in semicircles. And if you were asked to give the name of the rule that you'd used, that would basically be it. There are right angles in a semicircle. Now, it might be worth reminding yourself of the other circle theorems at this point, because they do come up. And there are, I think, maybe 5 that we need to know, apart from that. Maybe 6, let's see. So, in order, we have got double angle theorem, which is that the angle at the centre is double the angle at the outside. Let's call that dA. You have got cyclic quadrilateral theorem, which is that opposite sides add up to 180. Cyclic quadrilateral. You've got the rule that a tangent and a radius meet at right angles. Tangent plus radius. You have got that one that everyone calls bow tie theorem, but actually is properly called same segment, which is that the 2 top bits are the same. And then you finally got alternate segment, which is that bottom right equals top left. So yeah, have a think about those when you're doing the circle theorem questions. You need to make sure you know all 6. Going back to this, we want to find BAC, and that's literally going to be 180, take away 90, take away 24, which would give us 66 degrees. Okay, this is an algebraic fraction, and if we want to simplify an algebraic fraction, we are always looking to factorize and cancel out. Again, we've got the nice value of x squared, which means this is just x plus something, and they're all pluses as well, so all these will be pluses as well. We want numbers that times to 40 and add to 13 at the top, and those numbers are 5 and 8. We want numbers that add to 14 and times to 48 on the bottom, and those will be 6 plus 8. And you generally know you've done the right thing when 2 of them cancel out, which allows us to simplify what's left over, which gives us our final answer of x plus 5 and x plus 6. Okay, now the last question is fiddly. The last question is surface areas, and there are a few surface areas that are given to you in the exam. So if you wanted to have a go, the curved surface area of a cone is pi rl, and that's where L is like the length 9. And the surface area of a sphere is 4 pi r squared. And the way the GCSE is now, they will tell you those things when you need to use them. So I don't think it's fair of the question not to say them up front. Let's go on to the question now. So we've got a sphere, a cone, a cube. The surface area of the sphere is equal to the sum of the surface area of the cone and the cube. So we kind of need to do this bit first. We need to find the sum of the surface area of the cone and the cube. So let's do them one at a time. Cube. Surface area of a cube consists of a square times 6, because it's got 6 sides to it, like a dice. The square in this case has an area of 8 times 8, because it's a square side 8. So 64 times 6 will give us that the cube is 384 centimeters squared. What about the cone? Well, the cone consists of the curvy bit, which has got the pi RL. It's also going to have a circle on the base. So we need to do for this pi RL plus pi R squared. We know L is 9. We know radius is 3. So pi times 3 times 9 plus pi times 3 squared. I think that actually gives you like 36 pi, but we're going to write this as a decimal because the question is going to want us to work backwards with it, and it doesn't say anything about exact values. But those are our two surface areas. Now we need to add those together because we want the sum of them. So our number here is 497.1 centimeters squared in total. Okay, I want to find y now. So I've already said that the surface area of a cone, of a sphere rather, is 4 pi r squared. So we would say 4 pi r squared equals 497.1. And then what would our thing be with that? We would divide by 4 pi. So that'll give us that radius squared is 39.56. But we don't want that. We want the radius, which is y. It's the same thing on our sphere. So we square root that, and we'll get that the radius is 6.29 centimeters, and that's our value of y. Okay, so fiddly last question there. The higher plus is quite tricky this day. Let's go through them in order. So we start off with some indices. 16 in the form 8 to the power of n. So what you're basically asking yourself if you get this sort of question is, if I had 8 and I wanted to get to 16 and I wanted to do it purely using like powers and roots, how would I do it? Well, I would go via the number 2 because I know how to get from 2 to 8 and I know how to get from 2 to 16. 2 is the cube root of 8. So to get from 8 to 2, I cube root. And 2 to the power of 4 is 16. So what does this tell us? This tells us that if we had 8 and we were to cube root it, and then we were to put it to a power of 4, we would have 16. But we want to write it in this form, 8 to the power of n. So what does that mean? Well, it's 8. Cube rooted means the bottom of the fraction is 3. Power 4 means the top of the fraction is 4. 8 to the 4 thirds. And there you go. Okay. Rationalize the denominator. This means we need to make the bottom of the fraction into a whole number. And the way that this is done is by multiplying the top and bottom by the same amount, which is the denominator with the sign changed. So we're going to times it by 1 minus root 6. Everything you've got to do after this is expanding and simplifying with thirds. So let's do that. The top of this, root 3 times 1 is root 3. And then root 3 times root 6 is root 18. And the bottom of this, so this is a difference of 2 squares on the bottom. So you can actually cheat and go straight to like almost the answer, which is going to be 1 squared, take away root 6 squared. But let's actually show it in full for this time. So we'll have 1 plus root 6 minus root 6 minus 6. And the good thing about that is the middle bits will cancel out. So as I said, you'll get 1 squared, take away root 6 squared, which is just 6. So what do we have here? We have root 3 minus root 18 on the top, 1 minus 6 on the bottom, and that's just minus 5. Now, rationalise the denominator. All it means is make the bottom into a whole number, and we've done that. So, job done. Let's move on. Equation of a circle. Okay, so what you should know is that the equation of a circle is x squared plus y squared equals r squared. So that's telling us our radius squared is 225, and we could square root that to get that the radius of the circle is 15. What do we need to do? We need to find 5 coordinates of points that are on the circle. Okay, well, I can give you 4 points dead easily. If I know the radius of the circle is 15, then I can give you this point. That's 15, 0. I can give you this point. That's 0, 15. I can give you this point. That's minus 15, 0. And I can give you this point. That's 0, minus 15. But it does say that we want 5 coordinates, so how would we find another coordinate? Or how do you generally find a coordinate of a circle? And you find it by like subbing a value in. So let's just say I'm going to find this point here. I'm going to find a point that's like 10, comma something. So I'm saying x equals 10. And what I can do is I can substitute that into the equation. So x squared is 100. Y squared I don't know. And r squared is 225. I could then take away the 100. And I could square root the 125. And I could get that the y coordinate there is 11.2. Or I could just call it square root of 125, really, couldn't I? I'll do that. There you go. So I could find other coordinates by subbing in one value and getting out the value that goes with it. Okay. Then we've got the 2 tricky questions to finish off. Okay, so this one is distance, speed, and time, because it mentions speed and distance and time. And that's the triangle we want to use. But it's also bounds, because it talks about things being rounded to the nearest 10 seconds or correct to 2 significant figures. So when we're talking about bounds, we're talking about halve, add, take away, or hat. So let's work through this, okay? So here's Sam. 60 seconds to the nearest 10 seconds means we are going to add or take away 5. So it took him 55 to 65 seconds. Distance was 780 to 2 sig figs. So where's the second sig fig? Is the 8. This is in the tens. So again, this has been rounded to the nearest 10. If it had said 3 sig figs, we would have been the 0, that's in the ones, that would be to the nearest 1, and so on. So we add or take away 5, so 775 to 785 meters. What's the actual question? So you'll notice with a bounds question, you never really read it to start with, you just work out what the nearest stuff means. It says the speed limit is 50 kilometers per hour. Did he break the speed limit? Or could he have broken the speed limit? Now, this is meters and seconds, and this is kilometers and hours, so there's another problem here, which is that we need to change this to meters and seconds. So there's a third topic in here of unit conversion. So we've got 50 kilometers. Let me show you how this works. 50 kilometers in 1 hour. Let's change those to meters and seconds. So that is 50,000 meters, because there's that many meters in a kilometer. And an hour is 60 times 60 is 3,600 seconds. And then to do the conversion, all you need to do is 50,000 divided by 3,600, and that tells you that's like 13.9 meters per second. So our question is, or what we've simplified it down to is, was he going faster than that, or could he have gone faster than that? So we're trying to find like the fast version of Sam. We're trying to find the fastest that Sam could be. Now, the fastest that Sam could be, and bear in mind speed is distance over time, according to our triangle. We'd want the most distance that he's done and the least time. So the biggest distance is 785, the smallest time is 55. If we do that calculation, we'll get that the fastest Sam could have been is 14.3 meters per second. Could he have broken the speed limit? Yes, because 14.3 is bigger than 13.9. In-depth question, that one. Kind of hit like as many different notes as it could. Liked it. And then lastly we've got this one. Area of a triangle. So we know that area of a triangle is a half times base times height. It could also be a half AB sine C if we're dealing with some sort of trig. Let's see what we've got. Equilateral triangles mean that all of the sides are the same. It also means all the angles are the same. So we can fill in 60s for the angles and, I don't know, x's for the sides. We don't know anything about them yet. And we want to find the length of the side. So we're trying to find x. We want to do this to 2 decimal places. Okay. It says the area is 200. Now, which of these formulas is more likely to get used here? Well, we don't know the height. So it's probably this one. I think there's probably a way you could use SOHCAHTOA and a few more steps to use the first one, but now let's stay simple. And I tend not to think about them as A, B, and C. I tend to think about them as like 2 sides and the angle in between them. So let's take this as our A, this is our B, this is our C. So what have we got? We've got area equals 200. So that's going to be a half AB sine C. So filling in what we know, that would be a half x squared for the AB sine 60 for the angle. So to get just x squared on its own, we'd need to divide across by that half sine 60. And that would give us x squared is 461.88. I'm being this accurate because the question says it wants 2 decimal places, so let's use at least that. And then to get our actual value out of here, we just need to square root. So x is 21.49, yep, 2 decimal places, centimeters, because it's the distance. So it's actually only needing to know the formula there and like what an equilateral triangle means, but you've got to be careful with how you set it up. Okay, cool, that's the 28th sorted. I'll see you next time, guys. Cheers.